In this video, we'll take a closer look at two derivatives of the epidermis, hair and hair follicle, and nails. And so remember, to be a derivative of the epidermis just means that that structure is made of the epidermis. And so what I'm doing here is I'm tracing the boundary of the epidermis, and you can notice that the sebaceous gland, the hair follicle, that's all an invagination of the epidermis, or it's like the epidermis is burrowing down into the dermis, if that makes sense. And so these structures, exocrine glands, hair follicle, nails, they all have this in common. And what I'm trying to show is that it's actually an extension of the epidermis that is burrowing down into the dermis, and that's what's known as a derivative of the epidermis. Let's start by taking a look at this simple picture. And the portion of the epidermis that is extending down into the dermis surrounding the hair, this is the part that's known as the hair follicle. Associated with every hair follicle is a tiny muscle called the erector pili muscle. The erector pili muscle is just a little band of smooth connective tissue. When it contracts, it causes the hair to stand on end and causes what we call a goosebump. And then contained in the hair follicle is the actual hair. Each hair has two regions: the shaft that shows above the surface of the skin and the root that penetrates below the surface. Let's take a closer look at the bottom of a hair follicle to see some more detail. And so this white area that I'm outlining, that's the outer portion of the hair. Okay, and so this area is the actual hair. And then the pink area surrounding it and the blue area is the hair follicle. And so there are two parts of the hair follicle. There is the epithelial tissue that surrounds the hair. That part of the hair follicle is called the epithelial root sheath. This blue area is the portion of the dermis that forms the outside of the hair follicle. It's known as the connective tissue sheath. And so just like the epidermis and the dermis, let's take a look at this connective tissue that's surrounding the hair follicle. Notice how the connective tissue juts in to the bottom of the hair. That's just like a dermal papilla. It's called hair papilla, and this is the area where the blood supply comes into the hair follicle. The bottom of the hair follicle that we're looking at is known as the bulb, and when we take a look at the cells that are surrounding the hair papilla, these cells that surround that area are very active cells. It's known as the matrix, and the matrix is an area of rapid mitosis. So this is very similar to the skin itself. We're at the very bottom of the structure, close to the blood supply, are the active cells rapidly dividing by mitosis and producing the hair. We can see some melanocytes within the matrix, and the melanocytes do the same thing. They produce a pigment and inject it into the keratinocytes and give the hair its color. Also in this picture, we can notice the hypodermis, the adipose tissue. Taking a closer look at the hair contained within the hair follicle, you might notice that they're using color coding to show us that each hair has three regions. The most central region of the hair is what's called the medulla, and those cells are bigger cells, they're more spaced out. There's actually air pockets in that area. Outside of that, the cells are more tightly packed together. That's called the cortex. And then outside of the cortex, this white area is what's known as the cuticle. And the cuticle is highly keratinized, flat cells that kind of lay like shingles on a roof. The cuticle encases the entire hair. In this picture, you can see that there are two types of hair, both which have the same three regions we just looked at, the medulla, the cortex, and the cuticle. The pigmented hair that we would typically refer to as hair, that's called terminal hair. That would be the hair on the head, as you can see here, or eyebrows, eyelashes, etc. And then there's non-pigmented hair, like the hair that you can see on the surface of the face here. That's called vellus hair. Moving on to nails, which are also a derivative of the epidermis. Here we can see the free edge. We can see the lateral nail folds, which is the epithelial tissue on the sides of the nail. The epithelial tissue at the base of the nail, that's called the proximal nail fold. And then the little bit of epithelial tissue that grows onto the nail, what we would call the cuticle, that's known as the eponychium. In this view, we can see the part of the nail that is adhered to the finger. That's called the nail plate. And then there's a part of the nail, like the root of the nail, so to speak, that we can't see from the surface, and that's known as the nail root. The nail is lying on a bed of epithelial tissue, known as the nail bed, and the part of the nail bed that we don't see under the nail plate is called the matrix, and the matrix is the same as the matrix that we saw in the hair follicle. It's an area of rapid mitosis where keratinocytes are produced, highly keratinized, packed tight together in a plate-like structure, so that the nail is formed in the root and then it grows outwards towards the free edge. So to finish this up, let's just compare the hair follicle to the nail bed. We know that the hair follicle is this extension of epithelial tissue that continues from the epidermis down into the dermis. And the nail bed is the same thing. So just turning this picture to this orientation, notice that the nail bed in pink also is epithelial tissue that's surrounding the nail, that juts down deep into the dermis. And so the structure of a nail and a hair are very similar.